Good evening, ladies and gentlemen. Gianluca Masi speaking on the behalf of the Virtual Telescope Project, and it is a big pleasure for me to be live once again on the Virtual Telescope Project website and YouTube channel to share with you again something very special and something very unique. You know, the Virtual Telescope Project has been sharing many astronomical events live, bringing them to you no matter where you live on this planet, no matter where those astronomical events are happening. But with our systems based mainly in Italy, of course, we can cover more regularly things happening above the Italian sky when it is just clear. And we are really ready to observe the very close encounter between the Earth and the near-Earth asteroid 2012 ES3, and we are almost ready to bring all this live to you. And before I start, I want to thank all of you for being here, and of course I want to thank everyone for taking the time to check when this event is happening in your local time. You know, we always express our events in universal time, and I thank you for just checking at what time it is happening to you. And I also want to thank the technological partners of the Virtual Telescope Project, and they are Unitron Italia Instruments, Software Bisq, C-Web, Santa Barbara Instruments Group, Planewave Instruments, and Bader Planetarium. That said, I'm just going to share with you live images of the asteroid. As usual, we will be sharing with you no less than the telescope console, the one we are using to control the telescope. And here it is, my friends. In a matter of seconds, I just sharing with you the telescope console. Some of you should be just used to this graphic interface, because it is just what we use to control our robotic telescope. This software, which is very precious to observe, to use our robotic telescopes, is just showing us the stars above the telescope. I am in Rome. I'm operating remotely, and the telescope is about 100 kilometers south from Rome in Ceccano, where I grew up and where I started my interest in the sky when I was a child. And of course, all the stars there over there are clearly shown by the SkyX Professional we are using here to observe, to track the asteroid and so on. And of course, I really suggest you to have a look here to this yellow crosshair, because this one is telling us where the asteroid is in this very moment. And you can see that it is crossing a portion of the sky where we find the Camelopardalis constellation, and which is perhaps among the ones less known. And it is where the telescope is tracking in this very moment. The giraffe, of course.
Giraffe.
And it is the famous animal, you know. And the asteroid we are tracking, that is 2022 ES3, is the very sharp dot of light we see here. And it is amazing that we can see this very small and very fast moving object while it is approaching the minimum distance. This object, of course, is pretty small. It is somewhere between 10 and 21 meters. It is basically as large as the famous Chelyabinsk, meteorite, the one which hit the Earth a few years ago in 2013, about 9 years ago. And it is funny that at least we can observe a similar object, this time not hitting the Earth. By the way, a significantly smaller object had impact with the Earth, of course without any consequence. It was very small, just in the northern latitudes. 1 day ago, it was on Friday, yes, 2 days ago. And just to tell you that every time we talk about asteroids, we are talking about, which is it is a topic which is truly alive, you know. And this object, 2012 ES3, as I told you, has a size between 10 and 21 meters, as reported on the Jet Propulsion Laboratory website, which is a very precious reference for the work we are doing here. And I want to underline that we are seeing this sharp dot of light, while all around we see very long trails. What is happening here? It is easy to understand, because this object, which is really approaching the minimum distance in about 45 minutes, is moving pretty fast in the sky across the stars, and we asked the telescope, of course, to track the asteroid. So the asteroid is just in position. The telescope is working to keep its very powerful eye just on the object, focusing on the asteroid, and it is tracking the object while it is moving fast against the starry background. This is why the stars, of course, are showing as star trails, my friends. And every time I am amazed to see how great our telescope is doing this job. And as for the minimum distance this object is reaching, it is coming closer than our moon. At its minimum distance, the nominal minimum distance, it will be 334,000 kilometers from us, more or less 87% the average lunar distance. So this is why we defined this very close. We just use the lunar distance as a threshold. Something coming inside that orbit, it is for us very close. But please do not consider this dangerous, because this one is really going to say goodbye. It is approaching and will say goodbye without troubles. And this is happening, luckily and fortunately, many times. And you know, these little asteroids are coming so close and even closer quite often. And sometimes people ask why we see over the last years an increasing number of asteroids coming that close. Are they just there is something we did to the asteroids and they are coming to just to have us paying? Not. It is just that we are much better in finding the smaller objects. They are hard to locate. The smaller the asteroids, very likely the fainter it is through the telescope. So you need the technology increasing and improving to be able to see something that yesterday you were unable to see. This is just what is happening here, my friends. And again, the Jet Propulsion Laboratory is telling us that the minimum distance, that is 80% of the lunar distance, a bit more than 330,000 kilometers, will be reached in about 47 minutes by now. And while we are speaking here, friends, this is the asteroid. You see, as I told you, we are tracking this little rock, my friends, and the telescope is doing a very beautiful work. And this sharp dot is the asteroid, my friends. And let me see how far the object is in this very moment, because I also want to tell something about now, while hopefully waiting for the nominal minimum distance. And I'm just querying the Jet Propulsion Laboratory website. As I told you, it is a very precious resource for those doing our job, and I want to acknowledge the excellent work they are doing. And while we are speaking, let me see the time. Okay, it is 7:32 here in Rome PM. So let me check. Okay, my friends, let me do the conversion on fly. We are really doing this live, as you can see, as I am also checking everything in real time. So it is not a different distance. It is almost at the minimum distance, you know, because now the nominal minimal distance is happening in about 45 minutes. So it is not so strange that we are already there, basically. It is great, and also you have to consider that if you really want the distance right now of the telescope from the asteroid, it is 331,000 kilometers. This is the distance right now, in this very moment, we have between the telescope we are using and the asteroid. And as you can see, images are taking some time to show. And I'm just restarting our system to grab images, friends. And I want to explain what is happening. You are perhaps used to take a snapshot with your mobile, for example, when you are somewhere with your friends. You just point your camera, just click, and it is done. What happens when you are trying to image a very faint target, like in this case? This is incredibly fainter than the faintest stars you see by naked eye. And of course, we are using a huge telescope. And I also want to show you the telescope we are using, by the way, just to give you a better perception of what we are doing here. And this is the telescope we are using with the robotic mount, the red part of the instrument doing most of the job here, tracking basically. And okay, my friends, just let me check. Okay, and being so faint, we have just an option. Just collect the light coming from your faint object, the faint asteroid, for a number of seconds or a number of minutes, not a fraction of seconds as you do taking an image when you are staring on the sea, for example, when you have plenty of light. So you have to do a long exposure. If you are using to the photographic terminology, you understand what is a long exposure. And here we ask the telescope to take a 2 minutes exposure. You can read the exposure time here. I asked the system to start taking images, and the countdown is running, and we are 20 seconds left before we see the result. And of course, in 2 minutes, the object, the asteroid, which is very close to us and apparently moving pretty fast in the sky, is leaving just a very long trail up there. I mean, the stars. Otherwise, if I track the stars, as telescopes do most of the time, the asteroid will be a trail, but being that faint, the trail will be really just lost against the luminosity of the sky background. And again, here we have the object. And I invite you also to see how image after image the inclination of the star trails is changing. Just consider, for example, the angle you have between the star trail and the vertical axis of the crosshair, and image after image, that is an image coming every 2 minutes, plus the time you need to download the information from the camera. Okay, sometimes we have we read some comment on our live feeds telling it was not live because images were coming after a few minutes back to back. Okay, it was live, and it is Mother Nature asking us to do long exposures, my friends. So it is live. Live does not mean something happening many times per second, okay? Live is something happening now, and right now we are collecting for every image the faint light, just the little light coming from the faint asteroid for a couple of minutes every time. And you can track this in real time while this countdown is running from left to right, and we are now 2/3 of the exposure and a bit more than half a minute left, just waiting for this. And I really find really amazing every time an asteroid, an extreme asteroid, as I like to say, and I am always amazed to see how our robotic telescopes are able to do this. And let me say this, the robotic telescopes, part of the Virtual Telescope project, are among the very few on this planet able to virtually track everything moving up there. And this is why these beautiful, perfectly tracked images of these extreme asteroids are just published by the Virtual Telescope alone. And here it is, this faint rock. While it is approaching, it is also fading. This is not strange, because we have to consider who is playing here. We have the asteroid, of course, which is basically black, okay? But we are seeing some light. The light the asteroid is sending us, but that light hitting the asteroid is coming from the sun. So the sun is just sending its light to the asteroid, and the asteroid is just reflecting just a very small fraction of the light to us. But the asteroid is moving, okay? And basically it is going to show us its shoulders, its dark part, okay? Like the Earth, you have half of the Earth just in the daylight, and the other half of the Earth you have it in the night, okay, deep in the night, darkness. And while the asteroid is moving, the geometry is evolving, and basically the object is showing its dark shoulder and not its very bright face. This is why, no matter the minimum distance approaching, and you would expect that a close approaching asteroid, if it is coming closer, it should be brighter. It is right in principle, but you have to consider that the object is moving respect to the light source, the sun, and it is showing us basically a larger and larger fraction of its dark side of the asteroid, not the dark side of the moon, the dark side of the asteroid. So while it is just reaching the minimum distance, as I said a few times so far, my friends. Still up and running as part of the live feed offered by the Virtual Telescope project, and as I told you, keep an eye on the inclination, the evolving inclination of this long trail, and you can see how it is increasing, if I understand, in a clockwise direction. Just keep in mind. And again, a beautiful tracked object, a beautiful tracked asteroid, while it is shining in the giraffe constellation, Camelopardalis in Latin. All the official names of constellation are, of course, in Latin, my friends. The Lucamasi Virtual Telescope project is bringing to you live the Near-Earth Asteroids 2012 ES3, doing in about 30 minutes, and a very, very close but safe, I want to underline, it is safely doing a very close approach with the Earth, coming significantly closer than the Moon, 87% the average lunar distance, as I told you, but of course it is just a huge distance, and there are really no risks at all that this will hit the Earth. And something of this size actually hit the Earth in Chelyabinsk 9 years ago in February, and it is of particular interest to keep in mind that even an asteroid of this size can very locally could be a source of troubles, you know. So it is very nice that astronomers are just scanning the skies every clear night, just finding this kind of objects. And this one has been found from Kitt Peak Observatory in Arizona on March the 7th, so 5 days ago. And I want to congratulate with my friends and colleagues there who did this amazing discovery. And so it is very, very important, as I told you, that we keep an eye and we just count how many asteroids are moving out there, so that we can evaluate the real impact risk, my friends. I can now try to, let me reduce the exposure time to 30 seconds. Let's see if the object is still bright enough for us to enjoy it, so that we will have a faster frequency between the images. And I ask now the system, you see, to take 30 seconds of exposure. And let's see what will happen, my friends, right now with these choices. If you like what we are doing, you know, we are offering this for free, but of course, making everything operational, it is not free at all. And if you find what we are doing of interest, just consider if you want to support us by donations. You can visit www.virtualtelescope.eu and you can donate whatever you want. Here you can see we don't have a clear evidence of the asteroid, which will be here. This could depend also by the fact that this small asteroid is rotating pretty fast, and right now it is showing us the smaller section, so the minimum amount of light reflected, but we will see in the next image. It should be brighter. This could be, here it is, my friends. It is nice because the previous image was exactly the same as the one we are enjoying now, but the earlier image had apparently no objects, but now we see the asteroid. What happened? In the previous image, the asteroid, which is a very elongated shape at this point, was just showing the smaller section, and of course also the image, the light reflected to us was colored the same way. So smaller section, smaller amount of light, friends. Larger section, apparently brighter object. So this is a clear indication that the object is flashing. At this point, I want to do an experiment. Let's wait for this image. I will try to use just 15 seconds. And if you don't mind, let me wait for this other image to come. So if 15 seconds will be enough to see the object at its peak of brightness, we can perhaps enjoy a bit more this funny behavior. Now I resetted and I started the system to take 15-second long exposures, and let's see what will happen. Just waiting. The object should be here. It was already fading, you see, in the previous image, so I would expect no object now. But you know, never know. We see it. Very nice, very nice. Now you can see that the exposure now is about 1/10, because we started with 2 minutes, 120 seconds. We have now 15 seconds, about 1/10. And of course the star trails are now shorter, 1/10. No object now, you see. And at this point we can even try 10 seconds. Let's see what will happen. I really love doing this because we are doing this, my friends, together, okay? I can also reduce the dead time taken to show every image using Beam. That is just downloading a portion of the image. And this is something I will do soon after the new image. Let's take, friends, 7 seconds, and let's start now. Sorry, friends, I want to do also another thing here. This is just some technical things about calibration. Let's go with this faster imaging approach, more images in the same time span, to see if we can, here there is this shadow. This is very likely a galaxy, in fact. Okay, my friends, let's try to enlarge this a bit. And also let me adjust, because now I understand that we are really using very short exposure time, but the dot of light is here, just on the cross section, you see. And let's see what will happen. image after image. Now we have no object. Now we have the object back. I will leave the mouse arrow pointing where we should expect the asteroid. Showing back, my friends, look at it. It is nice to see this kind of things. Not only we are tracking a very close approaching object, but we are also observing a very fast spinning object. So in more or less the rotational period should be of the order of a few tenths of seconds. Look, now a star trail has the asteroid just superimposed to a star trail, but here it is back. And this is very nice to see together, my friends. You can see this one pretty well now. And we can try to evaluate the rotational period if we can find an image where very likely it is showing at the brightest, and you can find you find an image when the asteroid where the asteroid is showing at its brightest. Then you see the following images. It will very likely it will fade, and at some point it will rise again at the same brightness, and it could be an idea. The time between images showing the asteroid at the same maximum brightness, more or less, could give you an idea of its rotational period, my friends. Provided it is having, while it is rotating, its light curve, the evolution of its brightness over the time as a maximum per period. This is not necessarily obvious, you know. But still, we are having fun with this, my friends, understanding the beautiful realm of asteroids. It is just superimposed here to the crosshair, you see. I will wait for a few more images. And then I will ask the system again to be back with longer exposure to have fun and clearly have a much better vision of the asteroid itself. Tracking the near-Earth asteroid 2012 ES3, going to have a very close but safe encounter with our own planet Earth in about 25 minutes. And we are really tracking it so beautifully with the robotic telescope we are using. This very faint dot of light is the asteroid, and as you can see, its brightness is apparently dancing, showing a clear oscillation, because what we are seeing here, this is just telling us that this is a very elongated asteroid. The shape of this object is very elongated. It is rotating, spinning pretty fast, and in the dozens of seconds taking to this object to rotate, it is sometimes showing its larger section, sending back to us more light from the sun, and sometimes the smaller section sending less light and so showing fainter. This is asteroid for dummies in a handful of seconds, and all this happening live and reaching you to the comfort of your home via our robotic telescope, via the virtual telescope project. Very nice, I hope for you as well. no object now because it is too faint to be detected. When we use long exposure, we are just like 2 minutes, as we were doing earlier. We are just averaging over those 2 minutes the evolution of its brightness, and getting that average, you can record the object thanks to the longer exposure. Really hope you are having fun with us, my friends. It is always a joy to reach people to everywhere on the planet and bringing to you the beauty of the sky, the beauty of the universe where we live, and this hopefully will inspire us to be kind each other, my friends. Here the apparent brightness is increasing again. Sorry, need to enlarge to put on the same scale. Here it is. That very small dot of light is of course the asteroid, my friends. Let's wait for 3-4 more images, then I will switch to the longer exposure again. As I told you, it is while it is just dancing, it is oscillating because it's rotation. The general trend is that the asteroid is fading because its position is changing, and it is going to show to us more of its dark side than of the bright side, while approaching the minimum distance, my friends. Okay, let's start again with the 1 minute long exposure, so that we will see much better the object, my friends. I'm so happy to share the near-Earth asteroid 2012 ES3, safely going to have a very close encounter with our planet in about 25 minutes. And this is the magic of the virtual telescope project, and I really want to thank the thousands of people just looking at this with us right now, or who tried to understand better about this asteroid. As I told you, Virtual Telescope Project is always proud to share with you these kind of things: asteroids, comets, eclipses, exploding stars like supernovae, meteor showers. We did a lot of things. We brought to you many different astronomical events over these years. This is not strange because we increased the exposure time, and we need to check the brightness and contrast of the image. Here we are, and here it is, the asteroid, my friends. Beautifully tracked. Of course, earlier at some point I used just a portion of the of the imaging sensor to have faster downloading, and this is why, while I was doing that, the asteroid was just on the crosshair, because of course the crosshair has a fixed size, and if you reduce apparently the physical size of the image, it is the crosshair is apparently covering a different number of pixels. But this is the object. It was funny to see it blinking image after image. And I also want to show, wow, long star trail. And right now the object is leaving the Camelopardalis, the giraffe constellation, and it will be moving in a few minutes to the Cassiopeia constellation, which is much more important for the name constellation, of course. Let me see if I can enlarge this just a bit. Here we are, my friends. Let me see if I can. Okay, I changed the orientation. This is Camelopardalis, and this the asteroid is here. Of course, this is where the telescope is pointing, and this yellow crosshair is entering this portion of the area belonging to the Cassiopeia, the Queen. Just giving you an idea of its movement, together with the star trails we see in the image. So nice, so happy to share this with you. I forgot how many times we shared something like this over the years, my friends. Hundreds of near-Earth asteroids were shared with the public worldwide thanks to the Virtual Telescope project, my friend. We started this kind of experience in 2006, 16 years ago. Time is flying, my friends, very fast, too fast perhaps. And the Virtual Telescope is always bringing to you incredible things. Now you can really see how the inclination of the star trails has increased in the clockwise direction. When we started, the star trails were basically vertical. You should remember this. And now they are basically almost 45 degrees. Let me see if I can open another image. Let's go here, taking images at the beginning, when I started taking images of comparable length. Let me see which one could be nice. And let's see if we can compare this, for example. Look, this is very nice, my friends. This is exactly what I wanted to share with you. But here it is, the sky was still too bright. So let's take another image if I can, my friends. Let's take this one. Just perfect, friends. Look, they are the same object, and these were taken less than 1 hour ago. Look how star trails were almost vertical, but to be honest, they have an inclination. You can see, you can compare easily, and how the apparent motion changed in the sky, the apparent motion of the asteroid in less than 1 hour. This is to me, a nice comparison. And of course, the live image is the one on the left. And look how faint the object is right now. Perhaps this is the first time I just do, I underline this interesting thing during our live feed comparing. Again, I repeat, the live images is the one on the left. This one was taken earlier, and I can tell you exactly when, if I just scroll a few things here. Here we are. This one is 1 hour ago, my friends. Look, how curious is this? The image on the right, with the object here, was taken 1 hour earlier than the one on the left. And the difference between the orientation of the star trails is amazing. And this is just telling, of course, the star trails are reflecting actually the motion, the apparent motion of the asteroid across the stars, and the difference is huge. This is pretty nice, I believe, to look at. And we do look up, by the way. Every time really want to know what is happening over there. And in 14 minutes, the asteroid will be at its minimum distance. And while there is as I told you, the object is spinning, it is also relatively obvious that the asteroid is now fainter than earlier. Let's wait for the last these 10 seconds to run and see the new image. Again, I repeat, the live image is the one on the left. What will happen? Fainter, brighter, perhaps fainter. Let's see. Difficult to judge because you can see there is a star trail just involved with the asteroid. Let's wait for the other image. I really like, again, to bring all this to you via the Virtual Telescope project. It is always a joy and happy I had this idea to develop such a system, and you can really support the Virtual Telescope if you want to make more and more, but basically to survive, because while all this is free, the technology behind all this is not free. We have to pay bills, for example, maintenance and so on, upgrades, and if you want, you can support us quite easily, just donating whatever you want, visiting www.virtualterrace.eu, donate whatever you want, and you will have some little digital gifts back with some very exclusive images we captured over the years, my friends. Let's see the new image coming. Here it is. Look how different the inclination is. Just telling us how fast the apparent motion of this object is evolving in the sky. And it is also slowly moving west. Beautiful. Sometimes also silence is a nice comment when you face the silent beauty of the cosmos, my friends. Really hope you are having fun with this, and if we are learning something together, it is our joy, my friends. Sometimes fainter, sometimes brighter. I told you, this object is spinning in a couple dozen seconds perhaps. And sometimes we see the largest section. It is of course very elongated while it is rotating. This is explaining why it is apparently blinking so fast, also thanks of its very small size. We said somewhere between 10 meters, 20 meters, like the Chelyabinsk object which originated the Chelyabinsk meteor, and which partially reached the ground, and very famous now as the Chelyabinsk meteorite. New image coming, downloaded right now. Less than 10 minutes now to the nominal minimum distance, something we are waiting. and after that we will be closing the live feed, but at least we really want, for the record, as they say, to be here at that time. I also want to see a few things. For those of you used to astronomy, here you can see some data, the right ascension declination, that is the longitude and latitude in astronomical terms, and also other quantities like the altitude. Right now this is 48 degrees above the local horizon, and it is moving pretty fast, as you can see. If you know these units are seconds per second in right ascension, very pretty fast, also thanks to its north position. Look here, friends, we basically have no object in this image because for some reason we just sampled, I mean for the length of the exposure and the rotation, we just sampled the minimum brightness, which is quite faint, but we still have here an idea of the object. Let's wait for the half a minute left to the next image. And the image on the right, taken a bit more than 1 hour ago, is interesting because you can see how much changed the direction of the asteroid in the sky, and this is reflected by the changing in the star trail direction. Here we have the object superimposed to a star. Again, let me put this in the similar scale, apologize. Waiting for a bit more, 8 minutes to the nominal minimum distance, friends, which has an error of plus or minus 1 minute. I really want to thank all of you for joining us, for making this flight so pleasant for me to comment. Let's hope the next image will have no stars. We are almost at the minimum distance. Let me calculate, convert. Look how faint it is, my friends. Want to calculate okay. Let me say this, my friends, while we are speaking in this very moment, the object is at the minimum distance from our telescope. Right now, the asteroid is at the minimum distance from our observing site, that is our telescope. And in a few minutes, it will be at its minimum distance from the Earth's center. It is normal to have a little difference because there is a difference, you know, the Earth has a radius of more than 6,000 kilometers, and there is some difference between the geocentric center of the Earth and the topocentric distance, that is the specific observing site. So while we are observing now, it is at the minimum distance from our telescope, while the minimum distance from the Earth will be in a few minutes, and the minimum distance from our telescope right now is let me convert this right away, okay, it was 328,000 kilometers. Very nice, my friends. How faint it is now. So the object was already at the minimum distance from the specific telescope we are using, and it is now approaching the minimum distance from the center of the Earth. So nice to be here, bringing this to you live. The live image is the one on the left again. I just reduce the comparison one. Look how much now we are inside the Cassiopeia constellation. We crossed the border between Camelopardalis, the giraffe, and now Cassiopeia, the queen. Cassiopeia. And in a few minutes, 3-4 minutes, we will be at the nominal minimum distance from the Earth center, while we already shared, when I underlined that, the minimum distance from the telescope. The telescope is not in the center of the Earth. We are on the surface of the Earth, more than 6,000 kilometers from that center, and that is making a difference, okay? Look how faint is this. And we are less than 3 minutes left to the nominal minimum distance from the Earth, my friends. Up and running. And as I told you, the minimum distance from the Earth center will be 87% the average lunar distance. And as we commented, and this is 334,000 kilometers between, I repeat, between the Earth center and the asteroid. But while a few minutes ago we were a bit closer than this between our telescope and the asteroid, because of the size of the Earth, of course. We are almost there, for the record, while we already had the trailing of the minimum distance locally, but this is a global now condition, as it is referred to the Earth center, of course. And the one on the right, on the bottom right, again I repeat, it is the robotic telescope we are using, and the fantastic robotic mount, the Paramount MA, is tracking the object so well that we can see as a sharp dot of light despite its fast motion against the stars. And how fast is it easy to understand, because the star trails are so long, my friends. And we are there, basically, the minimum distance from the Earth center, 334,000 kilometers from the Earth center. This is the distance we have now between Earth center and asteroid. Let's take, for the record, an image right now, formally covering that minimum distance. Murphy will easily make a star trail crossing it, but in case we can try again, because right now we are just at the nominal minimum distance between Earth center and the asteroid, 334,000 kilometers, 87% the average lunar distance. That is significantly closer than the moon. And as we said many times, nothing happened simply because this was absolutely safe close approach. Let's wait for this image. Beautiful, friends. Again with the object at its peak. This is the image captured at the, as I told you, at the minimum distance from the Earth center, my friends. And this is like an image you can share and say, I was there while the object did this. Very happy. Just wait for this one, and then I will say goodbye after running for basically 1 hour, my friend. We are just touching 1 hour. I started a bit earlier, hoping this could be useful. Here we are with the latest image, grabbed live. With the asteroid now at the minimum, it will be nice to compare all of them. So here we are, friends. I hope you really had fun with us. And I really want to thank all of you for being here this evening. Gianluca Masi Virtual Telescope Project had the privilege to bring to you live images of Asteroid 2012 ES3 safely doing a very close encounter with the Earth, reaching a minimum distance of 334,000 kilometers from Earth center, 87% the lunar distance on average lunar distance, and it was even a bit smaller the distance between the telescope, which is on the Earth's surface, so some thousands kilometers closer to the asteroid, okay? And this is why I wanted to underline that. It has been a pleasure for me to bring also this event to you, and this is one of the hundreds of events we did over these years. I want to thank the technological partners of the Virtual Telescope Project. They are Unitron Italian Instruments, Software Bisq, Santa Barbara Instruments Group, C-Web, Bader Planetarium, and I really want to thank all of them. And I want to thank all of you for joining us, and I want to thank all of you supporting us. In order to survive, we really need to pay bills, and if you like it, this honestly rare and unique opportunity to spy no less than a very close approaching asteroids, you are kindly invited to consider the possibility to donate. Just visit virtualtelescope.eu website. There is a donate section, and literally you can donate whatever you want, helping us to be alive and to bring to you more and more and to develop more and more. That's all. Gianluca Masi from Rome, Italy is sending his best greetings to everyone. So good afternoon, good evening, good night, good morning, wherever you are on this common, beautiful planet we call Earth. Take care, my friends. See you soon on the Virtual Telescope Project. Keep looking up.